First up will be GE, and we have Emma McMullen and Justin Schrenko. Emma is a cyber intelligence analyst at GE and has served as the product owner for GE's internally developed attack tool. She specializes in Chinese APT tracking and assesses how Chinese national strategies align to APT targeting, patterns of intellectual property. Justin is a senior incident responder at General Electric and has worked at GE in various IR roles since 2011. Until recently, he was focused on CERT automation and orchestration, but now drives content development using the attack framework. And a fun fact, outside of GE, Justin is a member of the Michigan Cyber Civilian Corps. Please welcome Emma McMullen and Justin Schrenko.
Hey everybody, so thanks for welcoming us today. We can get right into it. So we're going to be talking to you today about summiting the pyramid of pain, operationalizing attack, and essentially how and why you should be integrating attack into your daily operations. So we started out with some fun facts, but apparently those have been spoiled for you. But a little bit extra, so Justin, you want to say something extra interesting about yourself?
That's actually me up in Mackinac Island. My families are really big campers. So Mackinac Island, middle of the Michigan Straits, it's kind of a rite of passage for young kids to ride their bike around it. So that's actually my son in the very background there, making his achievement.
And a little fun fact about me, I'm working on my third half marathon, and I'm also working on hiking through the desert in Dubai in this picture. But let's start in on the actual presentation. So what do we mean when we're saying summiting the pyramid? So for those of you who don't know, this is the pyramid of pain. And at the bottom, you have what we're talking about, more traditional indicators of compromise, right? So you've got hash values, IP addresses, and as you move up this pyramid, you're able to exact more pain on your adversary by being able to detect at those levels of indicators. So at the top, you have TTPs, right? Tactic, techniques, and procedures. As you move more towards behavioral detection, you're able to exact more pain. But that's something we all know, right? Like we're all trying to move towards behavioral detection. That's why we're all here. So really, when we were looking at the MITRE attack framework, the question came to be more how. How do we integrate that into operations? How are we actually able to improve our detection? So we knew we wanted to integrate attack into our daily operations, and largely this was why. So this annoying workflow you're looking at with the bright red boxes, this is the problem set. This is where we were pre-attack. So I know not a lot of you will have Intel teams or necessarily have a certain workflow with how they work with CERT. But for us on the Intel team, our main mission is to making sure that we're providing the best possible actionable intelligence to other teams like the CERT within GE. So that meant a lot of OSINT collection, actor tracking, and even traditional indicator processing. On the CERT side, they were doing things like detection creation, responding to incidents and alerts. The problem is we were getting kind of stuck in that cycle, which you can see when we're talking about those boxes at the end, daily briefings, some of the malware analysis, is that it kind of just got funneled into a database, and pretty much any time it ever got to the CERT was just through random ad hoc communication. We didn't really have a solid workflow to work together because a lot of times we were just speaking completely different languages to each other. So we knew, okay, we need to fix that. We know we need to move towards behavioral detection. The solution was really just one thing, just adopting the attack framework into those daily operations. So we knew that would allow us to break out of some of these siloed operations, and that an attack operational workflow that begins with intelligence collection and ends with detection deployed from that intelligence processing could drive better detection and help us work together. So what did that mean when we actually started that whole process? So the first thing, and I think we were kind of teed up for this before in some of the previous speakers, is that we knew on the intelligence collection side, we needed to start processing for more than just traditional indicators and more than just, okay, what is this actor doing and who's doing what? It's actually about processing based on behaviors and TTPs. So if you see as much as you can with the terrible loss of pixels in this image, that there's actually a PowerShell script here that we've highlighted. And that when you're looking at the annotation, the way that we did it is we pulled out the T number so that the CERT analyst in the future who's going to be looking at this can always refer back to the MITRE wiki. We have a tactic and technique labeled, but most importantly, we outlined the execution note. and we provided context for that PowerShell script, how it was being used. And that really is the rub of it, because whatever we were processing, we knew we wanted to have custom detection built for that at the end of this process. No more just sitting in a database never being used. So that eventually led to a spreadsheet, right? We all start in spreadsheets at some point or another. So each one of these lines is one of those TTPs that I annotated. So as we're going through our OSINT feed, I've annotated my report. I have all the behaviors pulled out. Each behavior is its own line. See the execution notes at the end. Seems simple, right? Should totally have streamlined our workflow. No. You can see here, that actually led to another spreadsheet, and eventually actually 4 different spreadsheets just to get through the whole process of doing quality assurance testing, making sure that certain intel were talking through how they were going to actually write detection from this. And unfortunately, so you're seeing on the one hand, we have kind of closed that intelligence gap, right? That's not there anymore. But you're still having ad hoc communication around some of the internal incidents, and this actually was a super time-consuming process. And furthermore, that metadata, there's so much valuable information in the patterns of behaviors in those spreadsheets, but it was just massively impossible to use. Because the more we were doing this, the more we became trapped in the spreadsheet of pain. If you see here, that's actually over 720 TTPs. We got there within 2 months of starting this process. So we were processing a lot. We were really happy about that. There was no way the CERT was going to be able to keep up with writing rules for all of that. And there was also no way anyone could really effectively search through that or even understand what you're looking at. So we knew that this just wasn't tenable the way that we were doing it. It wasn't going to scale. And we're telling you this because we hope that those of you who are still in spreadsheets can avoid this problem in the future. And that's why we went to TMAT. So that's the tool that I serve as a product owner for. And this is our in-house end-to-end attack tool. So you see, it might look a little spreadsheety still in some of those lines, but what's amazing about it is like the search functionality is so much more advanced and complex than just being in a spreadsheet. And the way that we built these different data objects really allows you to effectively pivot and learn a lot more about the relationships between different TTPs, actors, and really drill down into some interesting questions, which I'll get more into at the end. So that led us to our current workflow. So now all those angry red boxes you saw before have been replaced, right? So now if you see at the top, Intel and CERT are actually working together in one streamlined workflow. Intel starts it, then we hand it off to the CERT. We start out with actual integration, you have the report being processed, and it gets pushed through all in TMAT. And what the best part about this is that we are finally able to capture the metadata coming out of this. And that yields to much more interesting concepts of how you can map your own coverage if you're also documenting not just the intelligence you've collected, the TTPs you've processed, but also all the behaviors and rules that you've created that align to those TTPs. So this is what the new process looks like. So this is intelligence ingestion at the very beginning of the process. So we've got the annotated report, right? All the TTPs are still in there. But now you have report name, link, your ticketing system, whatever you want to use, and then you can just generate infinite TTPs. So you never have to worry about having like a really ugly spreadsheet that you're constantly scrolling through. They're all set data objects, and they always have the campaign affiliated with each TTP. So you're always able to closely map what actor is using what technique, but still pivot back to the original report or information source that it came from. And then we had to push through to quality assurance. So this is definitely still kind of new stuff, even though it's been around for a couple of years, right? It takes a while to train people up on how to actually process for TTPs, how you're writing detection. So we wanted to make sure that we had some of our more technical team members just do quality assurance for every TTP generated before it got pushed out to the CERT. So that way the CERT's not writing rules on things that didn't make sense, that they couldn't use, that weren't actionable, or were just incorrect. And that's where we got into detection creation. So now the CERT analyst, when they're looking through different TTPs, they can search, they can filter. So I pulled up PowerShell here. So for everyone doing bingo, you can mark that now. But you can actually search through, you could even type in a specific command you wanted to create detection for. And then you can annotate, okay, here's my hypothesis for detection, build out gaps, even talk about actionability. So then the Intel analyst in the future knows what they got right, knows what they got wrong, and we're always having that feedback loop to build better intelligence. But for now, I'm going to let Justin talk a little bit more about how we create detection.
So kind of back to the pyramid of pain here. GE cert's been around for a while, and it was essentially built off of network security mining principles. So we had this massive sensor grid in place that was looking at all of our ingress and egress type of traffic coming out, which led us to pretty easily capture a lot of the bottom part in some automated fashion that's backed by a pretty good quality assurance method. Along with that, we also had a pretty good handle on network hosts. So you're talking about traditional signature-based snort rules, all that good stuff. But we were kind of lacking on the really the tools and the pinnacle of everything, the TTPs. So what we were kind of faced with is your standard signature. You have a signature fires based on whatever subjective criticality that it was set on. Could be based off of actors, stuff like that. You set your critical high, medium, low, goes to your analyst. Your analyst has to go ahead and figure all that stuff out, what it means, false positive, true positive. But now moving to this new method, utilizing ATT&CK, we're allowed to attach a ton of metadata and generate behaviors. Our behaviors, which I'll kind of show an example in a minute here, could be more or less benign in nature. They're just something that happens on a system. Oh, right. Sorry, my mic was off. Could be things that were happening on a system, and what would normally happen every day might not mean anything. But when you start making detections for multiple behaviors, hundreds of behaviors, that might have a very low fidelity, and you start using the analytics, some people mention CAR, to kind of bring those together of what's actually happening on an endpoint, then you can start finding some really interesting things. If you start seeing more behaviors fire with a specific technique, you can kind of cluster your techniques together. You have 1, 2, 3, 4, 5 techniques. Those techniques could actually map to a specific kill chain section, so we still use kill chain. We did that by basically mapping a lot of our the MITRE techniques to kill chain behavior, and it just kind of gives us a better way to actually find out what's going on in an environment, and it gives a better picture to the analysts instead of just looking at a signature and figuring out yes, true, positive, or not. They actually have the information in front of them. So to accomplish this, we also did another method where we kind of mapped our tools to the attack data sources. So you need to have visibility, and to get visibility and to see these behaviors, we need to know what we could see. So we went through kind of a process of saying, okay, the tools are actually kind of blocked out in blue here. So those are our tools. You have your attack data sources, mapped out confidence levels to what we think that tool can see, which will later kind of build a confidence profile, which Emma will talk about. Key importance here of knowing this. So for us in the cert of creating behaviors, the content dev, we sit in TMET also. We essentially start out with the TTPs that they have that they've created for us. In this instance, they put in a report ID, the kill chain phase, the tactic, which is defense evasion, the technique, which is disabling security tools, and the note from the actual report. So in this case, the tool and or the actor interacting with the tool essentially just deleted the Windows event logs. Pretty simple type of behavior to detect. It could happen for a proper reason. Might not. So it's not going to be a very high fidelity behavior. It's not going to be something that we're going to automatically learn on every time we see it. But in order to do that, we have to essentially come up with the hypothesis to create the behavior. So the simple hypothesis is looking for a tool or command running and deleting the event logs on a system. Pretty simple enough, but there's multiple ways to do that. So we want to make our behavior as generic as possible. So you go out and do your research. How can you delete system logs off of Windows environment? Which leads us to the behavior creation. So this is the thing that's actually going to run in Splunk. That's looking for this specific behavior. It's going to look for the usage of Wintel delete, BC edit, and/or WinML WB-admin. So 3 programs instead of just the one note that the original note had mentioned. So with that, we actually also developed some type of a content dev CDI, CI system some things were mentioned a little bit earlier. We built something in-house, but our behaviors are based off of essentially two different files. We have a config JSON, which is the thing that actually holds all of our metadata, which our analytics are using to kind of bring all these behaviors together to make a true type of alert. And then we have the real file itself, which is essentially the search and or maybe a signature that you put in there. This process goes through really a QA process in itself. So you have Jenkins that does all these sanity checks, make sure that your syntax is correct, goes through a peer review process, and after that peer review process, it finally gets deployed out to our enterprise. So what?
Great. So you guys have seen a lot about that whole process end to end, right? So it begins with the intelligence collection and it ends with the signature being deployed. And it's all, again, based around behavioral detection, the attack framework. So you've seen the how, but why should you care? Well, because there's a lot more to this kind of process than just being able to deploy better detection. The metadata within this tool has actually proved to be amazingly valuable. So I've got a heat map up here. I'm going to start off by saying this is not a real heat map. This is dummy data. It's coming out of our sandbox. So just wanting you to know I'm not showing you where GE does or doesn't have coverage. But the cool thing is if you click into the green boxes, so that green obviously means that we've deployed behaviors to that technique. Now what's great about it is if I click into that green box, it pulls up every behavior. And even from there, I could pivot back to the hypothesis, pivot back to the TDPs, pivot back to the reports. It's that pivotability that always allows your analysts to have just a better understanding of the context and ask more complex questions. So when we get into coverage questions, which I know we all have leaders or maybe customers ask that, this really scary thing happened, are we covered? Well, now I could look into this and say, and while of course whether or not you've deployed a signature is just one aspect of that coverage, I could say, okay, well let me look at all the techniques that were used in that attack. Do we have green on all of those techniques? Okay, we have 80% of those techniques covered, but there's a couple that we don't. So let's prioritize detection for that. So that's getting deeper into understanding what your actual threat landscape looks like. But another great part of that coverage question, right, is the visibility. And that's what Justin was talking about with the confidence profiles and looking at your tools. So these are some graphs that we've mocked up that actually are, well, these are actually real. That's why we blurred everything out. So let's say this inner circle here, those are all of our vendors that we use, all of the tools that help us detect on things. So I've got vendor X highlighted. Now, all of those purple circles, those are all of MITRE's data sources, essentially saying, can this tool actually detect on those kinds of data sources? And then the outer circle is the confidence profile. So green being high confidence, yellow being moderate confidence, red being low confidence. So if I'm evaluating vendor X, I'm saying that actually covers a good chunk of that pie, right? Actually better than any of our other vendors. And from all of those data sources that it covers, it's actually in the high to moderate category for pretty much everything. So I'm feeling pretty good about vendor X. So then when my leaders come in and say, you know, we spent a lot of money on vendor X, was it worth it? Maybe I heard this other vendor was better. Or even I'll say, I want to compare it. I want to know, how does vendor X stack up against vendor Y? Is it better? How do they do detection differently? So I can look at this maybe bottom circle here. Let's say that's vendor Y. And I see actually vendor Y covers a much smaller portion of that data source, and also that almost all of it's in red, or at least yellow. It's not exactly a winning recommendation for vendor Y, right? And then that's maybe either feedback you can give to your vendors, you can understand where you might want to prioritize your dollars, but you just get a better understanding of what your coverage looks like. So that's why when the so what is that there's always value in the metadata, and that's why you really want to move to operationalize attack. So we've talked a lot about behavioral coverage and the capabilities that you can get from those analytics. But also, again, remember, it's just giving you better detection. So when we compared our attack alerts to our non-attack alerts, we found that our attack alerts had 124% higher true positive rate than our non-attack alerts. We were having our analysts spend a lot less time running down false positives and wasting their time. And some of the stuff that we're also starting to work on, enabled by TMAT, is actor tracking. So each actor can have its own specific heat map where we can map out techniques and see if we've deployed behaviors for it. And then prioritization. Are actors using one technique more than others? We can start prioritizing that for cert detection. So just to wrap it up, that the key takeaways here is when you have operationalization, you have better cross-team operations where teams are speaking the same language, working together, but also you're having higher fidelity in your alerting. You're also allowing to the support of intelligence-driven defense. So all of your detection is mapping back to trends that you're actually seeing in the wild. And then finally, the value in the metadata. You're going to be able to answer a lot more complex questions in analytics enabled by, again, that common language of attack. And with that, I'll yield to questions. Thanks.
Thank you, Emma and Justin. I'm just going to sneak in here. We know how the question and answer period works. We've been through this. We survived the last time. So does anyone have any questions? As we're waiting for someone to raise their hand. Oh, we have a question. Can we throw this man a mic? Or he can use that. I'm just going to stand over here.
So when it comes to actually deploying protective tools, there's a lot that's caught up in the capabilities that are actually deployed and how they're deployed. So how do you balance that with what you've presented here for management as a first question? Second question, it's a cat and mouse game. As those capabilities that are listed kind of get degraded and worked around, what do you do to shore those back up?
Sure. So I guess on the first part, a lot of what we're documenting as we're going through this process is not only what we can do with the hypothesis. Can we make a hypothesis for first is tracked. If we can't make a hypothesis, that's basically set out as a gap. So that gap is recorded, and it kind of flows back into our confidence profile, so that we can go to leadership saying that, you know, we really need to see this piece of information to get to the point of being able to detect this particular technique running over our environment. I think that's what you're asking for? Kind of, okay. So yeah, there is that feedback process for that. The second question, I'm sorry.
I can take that one.
Okay.
Yeah. So I think one of the cool things that we've got about this process is, okay, right, adversaries are always changing. The great part about attack is you're still just tracking their behaviors. And the best part is that since we've operationalized it, on the intel side, pretty much anytime we see reporting, OSINT feeds or things that we're learning through our shared intel communities, we can document that right away. So if an actor is changing its behaviors, we're documenting that, and that gets pushed through to attack. And then I know Justin's going to be picking up all the TTPs I pulled out and pulling detection for it. So it's that real-time kind of process that it's always working together, like nothing's just sitting around. It's actually always being leveraged, helps us respond actually a lot faster than we were before to map and discover and deploy signatures for some of those changing adversary TTPs. Does that answer your question? Mostly.
All right, other questions? Gentlemen in the back.
So for Tiamat, is there any thoughts about putting that open source and releasing it, or is it just going to stay an in-house app?
Yeah, I think we're still debating that on our end. It was never meant to be developed originally if we were going to have that be deployed open source or how we wanted to use it. But I mean, if we've kind of identified there might be a gap in the market, so possibly, but that's a question only our legal can answer for us. All right, yeah?
Another question.
Hi, so you've been using this process for a while in your operations. I'm assuming that you're not like finished. So where are your kind of like pain points where you see this going next?
That's a great question. So there's definitely still pain points. A lot of it could probably come down to automation integration. So there's still like a bunch of, when I'm looking at that heat map, right, that's just on behavioral coverage, but I know we've got so many more signatures we've already deployed that would map back to that. So going through a lot of that historical data is going to be a pain. We're hoping we could maybe automate some more of our integration with those signatures so that it's just kind of automatically ingested into the tool. And then future state stuff is kind of what I ended with, right? So that actor tracking component, and then technique prioritization. So I don't want Justin to have to maybe like search around constantly or like, maybe I'll do this or maybe I'll do that. You've got the top most dangerous like techniques always prioritized for you right away.
Okay.
Other questions? While people, oh.
Yeah, I guess two questions. I'll start with one and then go to the second one if no one else has questions. So first of all, I was wondering if you could talk more about the confidence levels, because so many people that we talk to or like, how do I determine what my coverage is or how confident I am in detecting something? Could you talk a little bit about how I think you did high, medium, low. How'd you come to that conclusion?
Sure. So, admittedly, some of it is actually subjective, but we have an understanding of what our tools are. Kind of the factors that we took into consideration is where we know the tools are deployed, what type of data those tools are looking at. Does that information actually give us anything useful for our purpose, our mission? Because we use tools used by other groups too, right? We get those data feeds. So it's kind of looking historically of how they've helped us in the past with investigations, former incidents, and then kind of meshing that up with how confident we are with, basically how well it's deployed and utilized and maintained. So there's a lot of things. It's not a purely quantitative way to figure out your confidence levels, especially on a tool deployment and what it's used for.
Yeah, and I would also say too, when we're doing those vendor comparisons, it's not like this one detects more on these things, so it's better. I would say like we take into consideration that different kinds of tools detect on different kinds of things. So it's not always like a one-to-one comparison,
Right.
but it just helps give you a more holistic view of what your vendors are doing.
Cool, thank you. And number two, I'm going to ask a threat intel question because that's what I do. I know it's been tough for us as we look through reporting, pulling out techniques. Some things don't go into a lot of detail about post-exploit. What challenges have you found, and any tips for anyone in overcoming some of those challenges?
That's a great question. So I remember when we first started doing this process, I think a lot of people on the Intel team was like, they're crazy, like that we're going to be able to like learn how to do this. But you actually can. The hard part is that not all reporting is created equal, unfortunately. So the first part that we always do when we start training on this process is how to determine actionability. Because I don't want Justin to be flooded with like a bunch of TTPs where it's like kind of you called out before, and they move laterally and like no detail at all. But we know they use this technique. That would pretty much not ever be used in a hypothesis.
Right.
So it's showing, okay, well, was there a screenshot of some of the code that was used? Did they really talk in depth about why they were doing something and like specific processes, how? And just really digging into what it means to have an actionable behavior, because not all things are actionable. Just because you're tagging it with a technique doesn't necessarily mean we can create detection for it. So that's something that's like a constant evolving process, but we've gotten a lot better at it, and I think we're getting much higher fidelity TTPs out of it.
Great, thank you so much.
So we are pretty much out of time. I just was going to sneak in one question of my own, which is you've obviously made a pretty big investment in ATT&CK. How in 60 seconds, how did you justify it? Was it difficult to justify, difficult to communicate to your leadership?
So I think we were pretty fortunate in that leadership was pretty on board from the beginning. Like we all knew that moving into the behavioral space was something we had to do. We needed to keep pressing onward about how to evolve our detection capabilities. I think the harder part was then justifying why we needed to build an internal tool for it. That's always going to be something that's hard. But I think we've actually been really lucky that we're starting to see great numbers coming out of it, better detection and better capabilities than we thought we were even going to get. Justin, do you want to add to that?
No, nailed it.
All right, well, please join me in thanking Emma and Justin.